Perfect. So, hello, everyone. Absolute pleasure. My name is Néstor, and as he said, I maintain two very cool projects recently. The main one is Module Federation, that maybe some of you know. Do anybody here knows what Module Federation is? Raise your hand.
I know. Before. I don't know about the rest.
Cool. And does anybody here know, by chance, RSPAC? 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 Cool. So yeah, so those are the two things that I maintain mainly. But today I want to take you guys kind of like in a journey to talk about a little thing about how software development works in the very big enterprises and when things get big. So usually pretty much everything that we do begins with an idea, right? And usually these ideas come to us when we are vibing these days, or it works sometimes when we are working together as a team. And eventually, when one idea successfully progresses, people start using it. Actually, a lot of people start using it. And successes usually makes this. It creates requests. It creates load, how it's usually called. And this has a very relevant problem, which is that people after this, in companies, want to add more things. So they want to add more developers. So they want to develop more things more quickly. And people, unfortunately, do not scale like servers do. When you have a problem with compute, you just add more vertical scalability into the thing, and it solves most of it, usually, especially these days. But when you add more people together, it creates more coupling, and it creates more issues within the organization. And work pretty much begins to be something kind of like this. It usually begins being kind of like a battlefield where people begin working on the features that they are developing and usually clash between each other in order to who is shipping it faster and who is blocking each other. And the big problem on big corporations is that there's not really one person that owns the entire thing and that knows how the entire thing works. And this happens because the problem that we are dealing with is not really that related to code anymore. It's more of a people's problem. And usually, most organizations suffer from this. And this is how myself and most of my team qualified. We usually tend to say that organizations are, by definition, dysfunctional. And they don't organize themselves as people properly, even most of the big examples that you can probably think of. And if we switch back to code real quick, backend teams suffer from this long ago, actually around 2010, if I remember correctly. They were beginning to stamp on each other's feet. And the solution that they came out with was this thing, which I hope everybody dreads here, which was called microservices, right? Any flavor of them. And the entire idea of this is that you will split your monolith application into different single applications that each team has their own stake on it. And because everything is decoupled and everything deploys independently, everything works well. And the first iteration of this that got famous was Docker, right? So everyone had their little container that they deployed independently, and everything is going to be fixed by this. And that pretty much lasted for about 5 minutes. Lots of complexity came out with this. So another guy, a couple of years later, came out and say, oh, I actually have a better idea, and this better idea is named Kubernetes, which is supposedly be easier than Docker, which in reality is not. This brought up a lot of more complex scenarios with orchestration, with service discovery, with network complexity. But of course, every single technology that I mentioned here was aiming not for developers themselves, but for organizational architecture and how people work with each other. And backends, at the end, and how we are today, most of the applications that we develop are classified as distributed systems, and they use these technologies in order to leverage themselves. Now, what happened to the front end, though? So the front end kind of went through something similar, somewhat. At the end of the day, we are way more limited than what backend services are. But the first iteration was this, iframes. So I want to know who here have the unfortunate luck to have worked with an application that dealt with iframes. Jesus, OK. I'm so sorry for you guys. But yeah, this came with a lot of complexity and horrible developer experience, in my opinion. But this led to especially this. This is what we like to call the following graph. So this graph is actually outdated today. Some of those logos are no longer like that. But that is pretty much a picture of the entire front-end ecosystem. Probably not today. I feel like a couple of those logos are not there anymore, unfortunately. But yeah, this is how it looks. This is how it connects each other. And this is, to be fair, an absolute mess. So it's chaos. And iframes essentially made this possible to work with everybody. Everyone could deploy their own leader application, and they could just interact with each other via iframes. And of course, this hurt some organizations the most. So Module Federation, the library that I developed, tried to fix this in a weird way. So the way Module Federation works, and very simple to understand, is that it creates a contract between two JavaScript applications in order to share JavaScript code between each other over the network. And that means that you can have one single application, old, in a monolith, that you can distribute into parallel applications. If we're talking about Vue, multiple Vue builds deployed independently, but then you have one primary one that gathers the content of the other ones and embeds it into oneself. So you don't have iframes anymore. You have a full app that at runtime composes itself and is capable of being able to deploy independently, and one team can own, such as like the header, and they just deploy the header and nothing else, and then there's a different team that deploys the host and is capable and responsible, usually, of making sure that the app composes properly. Originally, this was created on Webpack. So this comes back to 2020. This is the commit that merged Module Federation into the Webpack core. This is made by Sokra, one of the people that I think I don't know anybody that knows Rust better than him, Tobias. But today, this is no longer for Webpack. This is one of the biggest misconceptions about Module Federation there is. Module Federation today works anywhere. Works on Bit, works on ESBuild standalone, works on Rolldown, which is not there, works on Rollup, Rolldown, Parcel, even if anybody is using Parcel. But who uses this, right? This is the big question that people ask me, because this seems to be a problem that is meant for teams of thousands of people. And actually a lot of people uses this. This is a screenshot from this morning. This is one of the packages within the Module Federation ecosystem. That is the runtime, which is pretty much every single plugin uses it. And right now, we are sitting on almost 10 million downloads a week. We hopefully are going to close that before June arrives, and I'm going to be extremely happy. But the more impressive picture about this is the following one. So this is a picture of most of the companies that we consider to be big players that we know that have Module Federation integrated into their stack. So it's used pretty much on any company on the Fortune 500, pretty much somewhere, even though it might not be the entire monolith, but part of it. And by famous apps such as TikTok, such as Adidas website, such as Shopify, Spotify as well. It's pretty much everywhere. And the big part that not so many people know about this is that previously I said that it was to share in JavaScript. So it's not only for the front end, really. In fact, we have another package that is called Module Federation Node that brings these primitives to the Node ecosystem, so you can run Node applications and they can share JavaScript code between each other, yet being able to be deployed independently. And the cool thing about this, and here's where I'm announcing something, is that this means that there are things that run on the server that can use Module Federation without sending this massive package over to the user. And one of these things that we just made is that today this works with Next. So we implemented Module Federation for SSR, actually a couple of days ago. And if I check the right repo properly, it means that if you have, oh, don't tell me this. Oh, sorry, wrong example. I have a lot of things to show today. So this is a Next application that hopefully is not going to die on me. Oh, if the port is right, because I have these ports open. Sorry, this is a little spoiler. We will come back to this later. But essentially, Right. So this little application that you have here is one single Next app that if you were to look closely at the boundary, oh, this button doesn't work. Okay, this is what bytecode coding gets you guys. Anyway, this host application right here is a different application deployed in a different port that you can probably see if it were working here, which is apparently being restarted, but you get the point. And it is being consumed by a different Next application on the server, meaning on my laptop, and is being rendered back to the user as a single monolith application, which means that they can be built by different teams, and they can be deployed independently, shipped updates independently, and still being consumed as a single app at the end user. So, with all of this, right, which I hope you guys agree with me that this is super complex, and if we look at the numbers, which we will in a little bit, you will realize what I mean, deploying this thing doesn't become as easy as just stacking it into your Vercel account or stacking into your whatever account. It requires a very defined procedure of, I need to update this first, I need to update this after, and then after everything is updated, we update the main app, and everything becomes together as a single application. So the reason why I comment this is because as the team, we are about, what now, like 8 people maintaining Module Federation, actually a little bit more now, maybe around 10. We came out with one idea that we needed to help people be able to deploy this properly. And what we came out with was with something that some people actually here told me about, which I'm actually impressed, which was called Medusa. So Medusa is something that today it is absolutely considered legacy. It's completely dead. It died around 2.5 years ago or something like that, which was meant to provide you observability over these deployments. So it allowed you to see, oh, okay, so who updated first, who updated last, when, how, etc. And at the end of the day, when the entire application is deployed, it allowed you to see, oh, okay, so I'm using the version 1 of the host and the version 13 of the header, right? But that's not what really people wanted. What people wanted is being able to deploy this like I deploy my application today. And the reason, well, the logical reason was that, well, I need to be able to scale this to my entire organization. So what we came out with was we needed to kill Medusa, so we did. It is necked today. And we built something different. So this different thing is Zephyr Cloud. This is the company that I work at, and this is the product that we built. So Zephyr is heavily tied to Module Federation today, but you don't have to use it with it. And the main premise is that we are essentially the fastest way to deploy to any cloud provider. And to illustrate that, essentially, well, the way we work is that we basically took a very basic primitive that is essentially your build command, which is something that pretty much everybody uses, and we said, well, what if build actually deployed instead of just building? And the reason why we thought about this is because the bundler ecosystem, so Vite or RSpec or whatever, really exposes every single primitive that you know in order to understand what you need to deploy over into your website. So what we did is, okay, so we decoupled the traditional storage plus compute, which might be something like Lambda and S3, and we said, okay, what if every single time that you PnPm build, you uploaded everything into S3, and we gave you back one URL every single time? So essentially, whoops, that's a spoiler. If we go to one of my terminals, I don't know which one, is it this one? Oh, it is, cool. So if I open my editor, this is a very basic Next app that essentially, if you look closely, we have a Next module that we develop. We have essentially one for every major framework / bundler. So we have one for Vite, we have one for RSpec, we have one CLI if you don't use any and just deploy index.html to the web. And essentially, everything else is just like a regular Next app, like nothing crazy. But the main difference is that when you build this, let me make this bigger for you guys, something interesting is going to happen, which is that Nat is going to begin building, and we are essentially looking into the processes within the bundler And when the bundle finishes, there is one step that pretty much every bundler shares between them, which is called the seal. When the seal happens, we grab the output of the bundler, we put it together in a zip file kind of thing, and we upload it straight into the cloud, and we give you back one URL. So this URL right here is literally what I just built right here. And to prove that, I'm going to say, hello, MadVue. To save this, I'm going to build again. The main difference that you're going to see is that we are on build 50 right now. Now I am build 51, and this build has hello MadVue right here. So every single time that we deploy any application, this is what we do. Every single developer, every single person within the organization has its own versions, its own counters, its own versions of their apps. And this is important because when you are trying to deploy this over to real production, the deployment phase is nothing but a DNS change. There is no pipelines, there is no step processes, just a DNS change, and it's live on production. More importantly, if you break production, which is something that I do often, rollback is another DNS change. It is sub-second, happens automatically, and you don't have to care about anything. Also, another important thing is right here, which is that obviously someone of you, I saw you doubting, we don't upload everything every time. We do a diff algorithm, thanks to the bundlers, again, because they hash all the files that they compile. And we only upload the things that change between every build of every person within the company. So what is superposition that I mentioned on the talk? So superposition is something that Zach introduced. Zach Jackson is one of the infrastructure architects at ByteDance, which are the creators of TikTok. And the idea of superposition infrastructure is because we made this separation between compute and storage, it means that this compute can be spin up and down anywhere in the world, close to your users or far away, and they can just serve you whatever you asked for. So these URLs that you saw that changed, that had a little different number between them, are always live. All the URLs from everybody are live because the assets do not live on the compute layer. The compute layer gets created when I request it with my browser. Everything else is on an S3 bucket or somewhere kind of storage that your cloud supports. And it makes it so composition happens when you request it and only when you visualize it, which is very similar to quantum superposition, and I'm getting really nerdy here because we know these kind of things because we are developers at the end of the day. But essentially, that allows you to make, again, sub-second composition on the edge or on the cloud. So now I'm going to pitch something very quick, which is one of the things that we take use of this. So of course, I work in a startup, and of course, in this time and age, I have to promote AI somehow. So of course, we built a new platform based on this. This is our new AI platform. It is literally called the AI platform. And the entire idea was that thanks to Module Federation, we can provide a platform that you can tweak however you like. The base of this is that we want to bring the entire organization together. We don't just want to cater to developers, we actually want to cater to everybody. And the perfect interface for that was nothing more than a chat that pretty much everybody here probably uses on their companies. Call it Slack, call it Teams, call it Discord, call it whatever. And we essentially, on top of this primitive, we stack the things that developers like, such as a VS Code, such as a Chrome browser. And everything is bundled within a single binary, and this binary is capable, on this little sidebar that you have on the screenshot, to embed application that your company develops and your company deploys, and that is private and only for yours. So for example, we at Zephyr like to automate a lot of things. So in our personal workspace, we created a workflow kind of similar to NA10 or Node-RED, if you know what that is, and essentially made it into a micro frontend with its little backend, and we just added it to the sidebar, and now everybody within the company can use it, and everything works seamlessly thanks to the federation capabilities. Another example that I have that is kind of related to this, that I made, and this is purely personal. I want to know super nerd here. Who here knows what bad apple is? Bad apple.
The song?
Yes. Oh, you know what that is? Cool. So at least one person knows what that is. Cool. So bad apple is a very old animation. It is from 17 years ago, something like that. That is a black and white animation that is like 2 minutes long. So it is very famous and it's very big in the meme world. And I was actually trying to find use cases for federation because I'm that much of a nerd. And I found out that I could take that 2-minute-long video, grab every single frame of the video, turn every single frame into a frontend, and then load it at 30 frames per second and see if the browser doesn't blow up. So that's what we are going to do right now. So this took 3.5 hours to compile. Before, if anyone was around this area, I was literally there with my laptop, and my laptop was literally on fire with my fans full blast. And here, we are not going to have audio, I think, but just in case, I am going to open the network, and we are going to see roughly, I am going to say that's probably a gigabyte worth of bandwidth. So yeah, so here you have, there you go. So here you have every single thing that you're seeing here is one micro frontend exposing all of the entire CSS and HTML being loaded, rapid firing at 30 frames per second. So 30 frontends per second are being loaded into this, and they are being rendered. And you can see here that we are already at 5 megabytes, actually 20 megabytes. I'm just going to keep it going. So yeah, the point that I want to make with this is that it really wanted to cater to speed and performance. Of course, you're not going to be loading a gigabyte worth of bandwidth, hopefully, but it is capable of doing that on multiple platforms. So yeah, 24 frames per second, actually. I don't know. I don't know. It's fun.
Why not?
So yeah, that's all I wanted to say. Thank you. If you want to try the AI platform thing, this code right here will give you 15% off if you want to try it out. And the other one is just for me for cloud. So yeah, thanks everybody.